Is our effect of feedback on DC servo motor using PID controller trainer. This setup mainly consists of PID controller, power circuit, and this is our DC servo motor 24 volts with mechanical loading arrangement, and there we are provided a sensor for feedback signals for closed loop operation. In this we are provided a potentiometer to vary the set voltage or set RPM using this potentiometer, and this potentiometer to vary the gain of proportional controller, and this for integral controller, and this is for derivative controller, and this is power MOSFET chopper, power MOSFET based chopper. So, and this meter we are provided to set to indicate set RPM and an RPM for both in closed loop and open loop operation. This feedback signal input from the sensor, proximity sensor we are provided. That proximity sensor wires three signals we have connected, brown to red, blue to blue, and black to black, and output of frequency to voltage converter we have fed to the controller. Okay, this is set voltage you can measure here, and this error voltage point, and output of PID controller that we fed to the driver circuit output with this internally connected to gate and source of MOSFET. Okay, this freewheeling driver also connected across DC servo motor, and this mainly 230 volt mains operated kit, and in the mechanical loading arrangement setup we have provided scale arrangement with pulley attachment also there, and there is one provision for feedback using proximity sensor, and this output of the chopper we are connected to the motor, and you need to connect DC power supply from RPS to the DC input point, and the switch is provided here, and fuse also provided for production. To start the experiment, switch on the main supply, keep the switch at closed loop. Now set RPM, you keep it around 1000 RPM, 1000. Okay, now you switch to run RPM. Now you switch on this power supply to the MOSFET chopper, and switch on the proportional controller. Only P, we are the P switch is on, I and D is off. Now I am operating only in proportional controller. Now you switch on this and vary the proportional gain. Input is set at DC volts of 30 volts. And the gate, also switch on the gate supply. Now we can vary the proportional gain. The motor starts rotating, you can observe. Now this only for a proportional controller. In closed loop operation, even if you keep it at maximum gain, the set RPM is at 1000 RPM, run RPM is at 840 RPM. This never reaches the set RPM in proportional controller alone. So during this period, if you add I controller, this is for PI controller. Now you can observe, now they set the I gain at say 50%. Now you can observe the speed is come down to set speed with in PI controller. Now slowly it settled to set RPM is at 1000, run RPM also at 1000 RPM. Okay, now we can load the motor in steps. Load the motor in steps till that input current in the power supply reaches to around 600 to 700 milliamps. Should not go beyond 1 ampere. Now we can load. Now we can note on the run RPM also for different load in grams. Now the input is 0.2 amps. Now the weight is around 100 RPM, 100 grams. Now the RPM is remain at 1000 only, means almost 1000 only. Now we can load up to we stop for a few seconds. It takes time to settle to the set RPM. Now we can vary it till around 0.5 amps. Now we can note on the run RPM. It comes down to 1000 RPM. Now the weight, the scale is around 125 grams. So we have to take down difference of these two, and they almost set RPM and run RPM remains same only. Okay. For PI controller, now for PID controller, if we increase in PI controller, if we increase the I gain more, so motor starts oscillate, that we can observe here. So ideally we should keep it around 50% of proportional controller and 50% of I controller, and the D controller we can keep it maximum to get the performance. Good performance. Okay, and you can observe the waveform at waveform will be like this. And for open loop operation, just you switch off D controller, I controller, and proportional remains on only. You switch this to open loop. Motor continuously rotating. Only that proportional controller potentiometer only works at this time. I and D will not operate. While switching off, so switch off all controller, keep this to minimum, keep this potentiometer to minimum and set voltage to minimum, switch off the power supply, switch off the mains supply. This is about effect of feedback on DC servo motor using PID controller. Thank you.